All right. Nice to meet you all here. My name is Tobias. I'm the CEO of a company called HAIP Solutions. We are actually a quite young company within the space of hyperspectral imaging, and my talk today is about next generation hyperspectral imaging in the SWIR range. Just to give you a rough overview of our company, we have been founded nearly 5 years ago. We are based in Hanover, Germany. Currently 13 employees, and are mainly involved in the development and production of spectral imaging solutions, which can be hyperspectral imaging cameras on the one side, but also the accompanying illumination, as well as the software, which is crucial for the data acquisition and also the analysis in the end. We do have customers worldwide, varying from research to industrial, have a very direct sales and active distribution network within Europe, as well as Asia at the moment. As I'm not sure if everybody is familiar with the topic of hyperspectral imaging, maybe give us a quick introductory round into what it is exactly. So we see here the electromagnetic spectrum, and we human beings, we see only a small fraction of light, actually. So with RGB, red, green, and blue, we see only 3 channels. Hyperspectral cameras can see a lot more channels than we can see with the human eye. That's, in the end, the basics that we use within hyperspectral imaging technology. If we use those technologies, for example, to measure plants and parameters on plants, what we gather per pixel is a so-called reflectance spectrum, which is actually kind of comparable to a fingerprint. So that's also why you call it the spectral fingerprint. And each material, each surface has its own spectral unique fingerprint, and that's the basics that we use for the different application areas. Which actually brings me to my next slide. You can see a few of application areas that we are in, which involves food industry, agriculture, vegetation applications, plant breeding, but also environmental monitoring, recycling industry, and also some mineral geological applications. Our product portfolio is actually already quite diverse. We started out in the beginning with just linear-based systems, mostly within the environmental space in vegetation and agriculture. That's also where you see a majority of products are coming from. We have UAV-based cameras for the Matrice series from DJI. We have a handheld device with integrated illumination. My talk today will focus a bit more on the industrial section of our cameras, which is then the HAIP BlackIndustry series. You may remember this slide from before. Now with the addition of our different camera models in here, we do have cameras which are based on CMOS detectors and a few ones which are based on in-gas systems. It's always important to keep in mind that those are also, for example, in different price ranges and also have different technical specifications. That's why I have listed those here. If you look here around the fair, a big topic at the moment is SWIR cameras. So cameras that see from the 400 to the 1,700 nanometer range. Actually, what we do in our cameras is we split this up. We don't use SWIR cameras in one combined solutions because we think there's actually the potential that we have better sensitivity and better information if we do 2 separate devices. And here's the typical quantum efficiency curve that you see for the sensors that we use in our in-gas cameras. Which is also this model that you can see here, which we configure in the range from 900 to 1,730 nanometers. It's actually 3 different cameras that we can find here in this product range, depending on the spatial resolution. So we have cameras from 640 pixels to 1,280 pixels, up to 2,560 pixel resolution, which is quite a lot at the moment. So the majority of cameras that you find in the industry is around 640 pixels. And you can go with a multi-raw, you can go up to over 2 kilohertz in the frame rate. All of our cameras have integrated GPUs, so we use NVIDIA GPUs in there to do all the pre-processing of the data and also give out live information in real time about the things that you see, for example, on your conveyor belt. One very interesting thing here is actually that we are not cooling the system anymore. The system is actually temperature stabilized at a certain temperature that can be configured by the customer as well, which brings us also then very important information in the application areas. Let me start first with the recycling. So I guess everybody who's familiar with hyperspectral technology knows that NIR technology, as it is called in the recycling industry, is already used since like 10 to 20 years, mostly within the polymer space, because we can differentiate different types of polymers. A very new topic that is coming up, which is also heavily discussed, I would say, here at Vision, is the textile sorting. But very typical applications are also within the wood, paper, and mineral space. And one topic that is also coming out a lot is in terms of environmentabilities. Sustainability is the construction demolition waste, so to sort the demolition material that is coming from old buildings. If we look now in one specific application, which is the polymer-based stuff, we see here the typical spectral signatures of polymers. We see three types of absorption bands in the end that are very important. And the first ones are the ones that are mostly used also with other type of cameras. The very interesting thing here is that we now have a camera that is able to detect until 1,730 nanometers. And as you can see, there's a lot of information that is very crucial for the detection of polymers. And it's also the most intense absorption that you can find there. So in the past, a lot of cameras have been used until 1,900 nanometers for the PVC detection. This is actually not necessarily anymore because you can actually see it here right in this diagram. One thing that is also coming up is the increased spatial resolution. So we have now the worldwide highest spatial resolution hyperspectral camera in the SWIR range with 2,560 pixels. And just to show you one example from, again, the recycling space is the so-called flake sorting. So when you have, for example, PET bottles which are shredded in fine material, we want to sort out contaminants that are not that you don't want to have in your extruding process, for example, in the end, because it can cause damage on the extruding machine. And just to show you here three different examples, the grayscale, a fake RGB, which is kind of three different channels that we can use here for the image, and then also the classified result in the end. One big topic here as well is food industry. We can do ripeness measurement with hyperspectral cameras. For an object detection is also very important. You don't want to find any stones or foreign particles in your food products if you buy something in the supermarket. Rancid nut identification as well as sealing inspection. So a lot of food packages are actually transparent in the SWIR range, so we can see through the printed material. We do find a lot of water in the SWIR range as well. So the water absorption is pretty strong. So we can check actually, for example, the water content in dough before it goes into the oven. And we can also check it after the dough or the finished bread comes out of the oven again. So humidity control is also something that is very interesting in that range. And you can say, in general, improving shelf life, which you can do, for example, by detecting the bricks content, the sugar content. You can check also how mature a tomato, for example, is already. Again, to show you something here in terms of the spatial resolution. So we have an image here which is rice grains mixed with some plastic particles. And if you zoom just in one of this tiny image, in this image in one tiny area, you can see the rice grains, and actually you can see the starch content in each rice grain. So the amount of pixels that we have per rice grain is clearly phenomenal here. And if you use then the background filter that is done by our software and the classified result, it's actually a quite easy task to differentiate these two. But you can detect even the smallest contaminants within your waste, within your food stream. Next to our cameras, it's also important to have some sort of software. Initially, we actually didn't thought it as a product because we used the software mostly for our internal development during the sensor evaluation. But actually, there's a full software suite that is coming with our cameras, which can cover a lot of things. You have the first screen that you can find is always all the live information that's coming from the camera, which we call the capture screen, where you can also set all the technical parameters. Then we also have if you take an image or if you acquire a live stream of the camera, you can save that as a so-called hyperspectral data cube. So you have the 2D image, but you always have in the third dimension all the spectral information. And that is something you can use in the analysis screen, where you can then also do a classification. You can do ROI. You can set ROIs together the spectral signature, which you then see here on the right, and can also do false color images that can be created out of there. In the very recent update, we have also introduced a new functionality, which is a spectral or material database. So you can select within your hyperspectral data cubes, you can select certain areas which are then saved separately to reduce the enormous amount of data that you have in these systems. Because with every hyperspectral camera, especially in this high spatial resolution, comes a lot of data. And as you can see, for example, from this one image here, not all of the images may be necessary. A lot of things is background, and we don't need the background in the end for further classification. The nice thing here about this material database is that we are actually saving this tiny snippets, how we call it, and you can actually always load them again into a so-called canvas view, where you can really drag and drop those individual elements, and you can retrain models that you have already acquired beforehand with data that you have new, for example, gotten from customers. You can add them on this classifier as well. For all people who are then also doing sorting and want to have statistics, for example, coming from their conveyor belt, we have a new live classification feature built in as well. You can also do your valve control. So if you have the connection of air valves, which sort out the foreign objects in your material stream, this can be done with the software as well. And then you can also see how many percentages of my materials are in this stream. A very important new feature, which we are also showcasing at our booth, so we are happy to invite you to come over there, is now that this edge computing is actually possible on camera. So we do this real-time classification and the result output through the NVIDIA GPU, which reduces enormously the data amount, and there's also no external industrial PC needed anymore, which you all may know is quite expensive, which is then ideal for the inline process control, analytics, and the sorting task. You see the typical workflow that is needed here. So first we do some acquisition of training data within the software. You can train the classifier in the analysis tab, and then this classifier is transferred onto the camera and actually then deployed on the camera, and you get the real-time results output as a classified color stream in the end. One topic that we are proposing right now is actually that the conventional systems are mostly being used as halogen illumination. During the camera development, we figured out halogen illumination is actually not perfect if you look on the full SWIR range. And there's different type of IR emitters that can also be used in that sense, which is a so-called fast medium wave IR illumination. And this is a lot better peak response. So the peak response of this illumination is at 1,500, 1,600 nanometers. And typical halogen illumination has the peak response at 1,100 nanometers. So really at the front, but especially if you look on the polymers, actually the relevant information is actually at the back end of the spectrum. So if you shift also the illumination in that end, we will get way better results in the sorting process. And the illumination is more equal in the full range of this camera. That's it from my side so far. We are located in the next hall, booth 10, booth 10 E70, in the joint booth from our government. I would be happy to welcome you there, but I'm also open for any further questions. Thank you.
Big applause. So thank you very much for the nice presentation. Thank you very much for staying perfectly in time. So there's room for questions.
Hello.
Hi.
Thanks for your talk. How are the specifications for the speed, like frame rate, and for the spectral resolution?
Yeah, it depends a bit on the camera. So each of those sensors have different sizes also, and therefore it depends really what exactly you need. If you have more interest in that, I would recommend you to come over to the booth and we can discuss it in details. Otherwise, all the technical data sheets can be found on the website as well, so you can download them there and check it out as well.
Okay, thanks.